Welcome to Elevate Learn. In this tutorial, we're diving deep into one of React's most powerful hooks, useEffect. Side effects are operations that interact with the outside world, like fetching data, updating the DOM, or setting up subscriptions. If you're building modern React applications, understanding useEffect is absolutely crucial. By the end of this video, you'll know how to manage side effects effectively, handle cleanup, and follow best practices. Let's get started. A side effect is any operation that affects something outside the scope of a React component's render function. Think about what happens in real applications. You need to fetch user data from an API, subscribe to events, set up timers, or update the document title. These operations are side effects. Without proper management, side effects can cause memory leaks, infinite loops, and unpredictable behavior. React's useEffect hook provides a safe, structured way to handle these operations. It ensures side effects run at the right time in your component's lifecycle, preventing common bugs and making your code more maintainable. The useEffect hook has a straightforward syntax. You import it from React, then call it inside your functional component. It takes a callback function as the first argument. This is where your side effect code lives. By default, useEffect runs after every render. This means if your component renders 10 times, the callback runs 10 times. While this can be useful, it's often inefficient and can cause problems. That's where the dependency array comes in, which we'll explore next. Understanding this basic structure is fundamental to mastering useEffect. The dependency array is crucial to controlling when your effects run. If you provide an empty array, the effect runs only once after the component mounts, perfect for initialization tasks like fetching initial data. If you include dependencies like state variables or props, the effect runs whenever those values change. This is incredibly powerful because it lets you optimize performance and prevent unnecessary side effects. Think of it this way. The effect watches the dependencies and only executes when they change. If you omit the dependency array entirely, the effect runs after every render, which can be expensive. Always be intentional about your dependencies to avoid bugs and performance issues. Let's look at a real-world scenario. Fetching user data when a component mounts. We use useState to store the user data, then useEffect to fetch it from an API. By providing an empty dependency array, we ensure the fetch only happens once when the component first loads. This prevents unnecessary API calls and potential infinite loops. Notice how the async fetch call happens inside the effect callback. This is the proper pattern for handling asynchronous operations in React. Without useEffect, you'd likely make API calls during render, which causes problems. With useEffect, you have full control over when data fetching occurs, making your application more efficient and predictable. Understanding dependencies deeply is key to writing correct React code. When you include a variable in the dependency array, React watches it. If the value changes between renders, the effect runs again. You can include multiple dependencies. The effect runs if any of them change. Here's a critical point. React uses object.is for comparison, which means for objects and arrays, even if the content is the same, a new object or array will trigger the effect. This is why you need to be careful about how you create dependencies. If you use an object as a dependency but create a new object on each render, the effect runs every render. Mastering dependencies prevents bugs and optimizes performance significantly. One of the most important concepts in useEffect is the cleanup function. When you return a function from your useEffect callback, React calls that cleanup function before the effect runs again, and when the component unmounts. This is crucial for preventing memory leaks. Imagine you set up an event listener without cleaning it up. Every time the effect runs, you add another listener. Soon you have dozens of listeners doing the same thing. The cleanup function solves this. You remove event listeners, cancel subscriptions, clear timers, and undo any setup you did. This pattern ensures that each effect properly cleans up after itself. It's a best practice that separates professional code from buggy code. Let's look at a practical cleanup example with timers. A stopwatch component sets up an interval that updates the time every second. Without a cleanup function, if the component re-renders or unmounts, the old interval keeps running in the background. You'd have multiple intervals competing to update state, causing unexpected behavior. The cleanup function solves this by clearing the interval before the effect runs again or when the component unmounts. This pattern is common for any resource that needs to be released: timers, subscriptions, API requests, DOM observers. Always ask yourself, what setup does my effect do and what cleanup is needed? This mindset leads to robust, leak-free React applications. React allows you to use multiple useEffect hooks in a single component. Rather than combining everything into one massive effect, you can separate concerns. One effect fetches user data, another fetches posts, another sets up a listener. This separation makes your code much more readable and maintainable. Each effect focuses on a single responsibility with its own dependency array. This is cleaner than one effect trying to do everything and having a huge dependency array. It also makes it easier to add, remove, or modify individual effects without affecting others. Don't be afraid to use multiple effects. It's a feature, not a limitation. Infinite loops are a classic pitfall when learning useEffect. Here's how they happen. Your effect runs, updates state, the component re-renders, the effect runs again because of the re-render, and the cycle continues infinitely. This especially happens when you forget the dependency array or include state that the effect updates. The browser becomes unresponsive as React constantly tries to update and re-render. If you suspect an infinite loop, open the console and look for repeated messages. You can also add a counter and log it to see how fast the effect is running. To fix it, carefully consider which values the effect truly depends on, and only include those. If the effect updates state, be intentional about the dependency array to break the loop. When your effect uses props, you must include those props in the dependency array. This ensures that whenever a prop changes, the effect reruns with the new values. In our user profile example, if the user ID prop changes, we want to fetch the new user's data. Without user ID in the dependency array, the effect would use the old user ID from when the component first mounted. Including user ID ensures the effect always uses the latest prop value. This is a common requirement in real applications where components receive different props over time. Understanding how props interact with effects prevents subtle bugs where your component doesn't respond to prop changes as expected. Sometimes you want an effect to run, but only under certain conditions. You can add conditional logic inside your effect callback. For example, you might only want to subscribe to messages if the user is logged in. Rather than creating complex dependency arrays, add a simple check at the beginning of the effect. If the condition isn't met, return early, the effect does nothing. This makes your code's intent clear and easier to understand. You can also have conditional cleanup. Perhaps you only need to unsubscribe if a certain condition was true when the effect set up. This flexibility makes useEffect incredibly powerful for real-world scenarios where effects depend on multiple state conditions. This is a subtle but important concept. React compares dependencies using reference equality, not value equality. What does this mean? Two objects with identical properties are not equal if they're different object instances. In the bad example, a new config object is created on every render, so the effect sees a new dependency each time and runs again, even though the config content hasn't changed. This causes the effect to run every render, defeating the purpose of dependencies. Solutions include defining the object outside the component, using useMemo to memoize the object, or being more specific about which properties you depend on. Understanding reference equality prevents the frustrating bug of effects running more than expected. One of the best practices for using useEffect is enabling the ESLint plugin for React hooks. This plugin automatically checks your code and warns you about missing or incorrect dependencies. It catches cases where you forgot to include a variable in the dependency array, which would cause bugs. It also warns about unnecessary dependencies that might cause excessive re-renders. Using this linter transforms useEffect from something potentially confusing into something much more reliable. It's like having an experienced React developer review your code in real time. If you're not using this plugin, enable it immediately. It prevents countless bugs and is considered essential in professional React development. When you fetch data and the component unmounts before the fetch completes, React warns about updating state on an unmounted component. A Bork controller elegantly solves this problem. You create a controller, pass its signal to the fetch, and then abort the request in the cleanup function. If the component unmounts, the abort prevents the fetch from completing, so the response handler never runs. This prevents the state update warning and unnecessary operations. Abort controller is part of the modern JavaScript standard and works great with async/await. It's more elegant than checking if the component is mounted before updating state. This pattern is increasingly becoming the standard approach in production React applications. useEffect has many practical applications in real-world React development. Data fetching is the most common, loading user data, posts, products from APIs. You might subscribe to real-time data sources like Firebase or WebSocket connections. DOM manipulation like updating the document title or focusing input fields are common. Form validation happens in effects when input changes. Analytics tracking reports user interactions. Event listeners set up when a component mounts and clean up when it unmounts. These patterns repeat constantly in professional applications. By mastering useEffect, you unlock the ability to build sophisticated, interactive applications. Understanding these common use cases gives you a foundation to handle almost any side effect your application requires. The dependency array is your tool for optimizing performance. By being specific about dependencies, you prevent unnecessary effect executions. If you have a complex data fetching operation that runs on every render without a dependency array, your application becomes slow, potentially making API calls hundreds of times per second. With a proper dependency array, that same effect runs once on mount. This is a dramatic performance improvement for free, just by thinking carefully about dependencies. In large applications with many effects, this compounds. A component might have 5 effects, each running on every render without dependencies. Fixing them with proper dependency arrays transforms the application from sluggish to snappy. Performance optimization through proper useEffect usage is often overlooked but incredibly impactful. Testing components with effects requires special consideration. You need to verify that effects run at the right time, on mount when dependencies change and not unnecessarily. React Testing Library provides tools like waitFor to handle asynchronous effects. You mock API calls so tests don't hit real servers. You verify that cleanup functions are called when components unmount. These tests ensure your effects work as intended and prevent regressions. Good test coverage for effects catches bugs before they reach users. While testing effects takes more setup than testing pure components, it's essential for reliable applications. As you grow as a React developer, understanding how to test effects separates junior from senior developers. Race conditions are tricky bugs in async effects. Imagine a user rapidly changes a search query. The first search request is slower and completes after the second one. If both update state, you end up with results from the first search, not the second, confusing users. The traditional solution uses an isMounted flag. You track whether the component is still mounted and only update state if it is. The modern, more elegant solution uses abort controller. You abort the previous request when a new effect runs. This prevents stale updates and is cleaner code. Understanding and preventing race conditions shows sophisticated React knowledge. Most developers encounter these bugs painfully before learning to handle them properly. Recognizing the pattern and implementing proper solutions demonstrates professional expertise. Let me share the most common mistakes I see developers make with useEffect. First, forgetting the dependency array entirely. The effect runs after every render, causing repeated API calls and subscriptions. Second, not cleaning up after themselves. Event listeners and timers stack up, leaking memory. Third, trying to use non-reactive values from outside the effect scope inside it. The effect captures old values and behaves unexpectedly. Fourth, having incomplete dependency arrays, including only some of the values the effect uses. Fifth, trying to put async/await directly on the effect callback. Effects should return a function or nothing, not a promise. Learning from these mistakes is how developers graduate from frustrated beginners to confident experts. If you've made these mistakes, you're an excellent company. Every React developer has. The key is learning and improving. Once you master useEffect, the next level is creating custom hooks. Custom hooks let you extract and reuse complex effect logic across your application. Instead of repeating data fetching code in every component, you create a useFetch hook that handles it. The hook manages state, effects, cleanup, error handling, everything. Components using the hook are cleaner and simpler. This pattern scales beautifully. You build a library of custom hooks tailored to your application's needs. Custom hooks represent a higher level of React mastery because you're not just using hooks, you're creating abstractions with them. Professional React codebases are filled with custom hooks that encapsulate business logic and side effects. Learning to think in custom hooks changes how you structure applications. Congratulations! You've learned React's useEffect hook comprehensively. You understand what side effects are, how useEffect manages them, and why dependency arrays are crucial. You know how to clean up after effects, preventing memory leaks and bugs. You've learned to avoid common pitfalls like infinite loops and race conditions. You understand that useEffect runs on mount with an empty array, on prop changes with dependencies, and can be split into multiple effects for clarity. You know testing patterns, performance optimization, and how to handle complex async operations. Most importantly, you have a mental model for thinking about side effects in React. As you write more React code, practice these patterns. Try different approaches, make mistakes, and learn from them. useEffect is fundamental to modern React development. With this knowledge, you're ready to build sophisticated applications. Thanks for watching Elevate Learn. Subscribe for more React tutorials.